with three variables, which we ended with yesterday, but this one actually has three equations as well. So we should be able to get a solution from it. So if I look at this one, first we write our matrix. So our goal, we know we need ones in the diagonal, zeros elsewhere. Same idea. You start in the first column, you get the 1 in the first column, then you get the zeros in the first column. Right? So I already have my 1. Next, I need both of those to be zeros. You can do it in two separate things, or we can just do it in one step on the matrix, which is what I'm going to do. So I'm not going to change my first row, but I need to get zeros for both of those. So row 2. If we start with row 2, it is currently a 3, so we have to subtract 3. And we always know we have to take it times something, because we can't just have a number. Take it times the row we're not changing. Okay, we have the 1 in row 1, we're not changing that, so we're going to subtract 3 of row 1. Row 3, we start that, it's row 3, it's a 1, so I just have to subtract 1 of row 1. So on both of these, we are using row 1, because that's the row that has a 1 in that position. That's the row we are not changing. So 3, and you write out as much work as you need to, minus 3 times 1 is 0. Next one, 3 minus 3 times negative 1 would be negative 1 minus 3 times 5, so negative 1 minus 15. Last one, 10 minus 3 times negative 6, so that's 10 plus 18. All right, then row 3 minus row 1, so 1 minus 1 is 0. 3 minus negative 1, 2 minus 5, and 5 minus negative 6. Now, column 1 is done. So what's the next thing we need? Row 2, column 2, that has to be a 1. What's the easiest way, never fail method of getting a 1? So I am only changing the second row here. So 0 times 1/6 is still 0. 6 times 1 over 6 is 1. Negative 16 times 1 over 6 . And 28 times 1 over 6 . What is the next step? Alright. So this time, row 2 is the row we are not changing. So row 2, that's the one that has a 1 in this position, that's the row we will be using to get our zeros. So row 1, if you start with row 1, it is a negative 1, so we would have to
Just
okay. Row 3, starting with row 3, it is a positive 4, so we need to subtract 4 of row 2. Again, using the same row for both of these because that's where I have my 1. Alright. So 1 plus 0 is still 1. Negative 1 plus 1 is 0. 5 plus negative 8/3. It's a negative 8/3.
Oh.
And then negative 6 plus 14/3.
Negative 4/3.
Alright, last row. Row 3 minus 4 of row 2. So 0 minus 4 times 0 is still 0. 4 minus 4 times 1. Negative 3 minus 4 times negative 8/3.
Negative
11 minus 4 times 14/3. Okay. Column 2 is done. What's next?
Multiply by 3/23.
We need that to be a 1. So we multiply that 3 over 23. So 3 over 23 times 0 is still 0. 23 over 3 times 3 over 23 is 1. Negative 23 over 3 times that would be a negative 1. Is everyone with me so far? So, last thing, we need both of these to be 0. So this should be our final matrix before I answer. The row that we are not changing is row 3. So we will add multiples of row 3 to get this. So row 1, starting row 1, it's a positive 7/3, so we have to subtract 7/3 of row 3, because that's the one that has a 1 in that position. Okay, for the second row, start with row 2, it's a negative 8/3, so we would add 8/3 row 2. Sorry, row 3. Okay. 1 minus 7/3 times 0 is still 1. 0 minus 7/3 times 0 is still 0. 7/3 minus 7/3 times 1 is 0. Negative 4/3 minus 7/3 times negative 1 2 plus 8/3 times, or sorry, 0 plus 8/3 times 0 is still 0. 1 plus 8/3 times 0 is still 1. Negative 8/3 plus 8/3 times 1 is 0. 14/3 plus 8/3 times negative 1. So my answer
X equals 1, y equals 2, z equals negative.
and then just write it as an ordered triplet.
I have a question.
Yeah.
So like with this, could like at any moment you like switch to like regular, like substitution and elimination?
I mean, technically yes, but if I'm asking you to use the matrix to solve, then you would have to finish it this way. But if I just said solve it and you decided to start with the matrix and got to a point where you're like, oh, I could easily finish this using a different method, sure, it would
Okay.
work. Other questions? So it got a little bit longer. We had a couple more steps, but not really that much for adding a third equation. If I added a fourth equation, it would only add a couple more matrices to our solution. Versus if you're trying to do substitution and elimination, you know, we would probably use a whole sheet of paper trying to do 4 equations. So that's where the trade-off really starts to happen, when you have the 4 or more. That's when this saves a lot of time versus elimination. Let's try this problem. First matrix. 2, 2. There is no z, so we put a 0. 6, 1, 1, 1, 1, 3, 4, a 1, 3. So there's really at least 3 different ways we could get a 1 in row 1, column 1. Yep, you could flip rows 1 and 2. That would work. What's another way? Multiply by a half, and that works. What's a third way?
Subtracted by 2 times row 2.
You could subtract, that would give
I
it
mean,
to 0.
subtracted by row 2.
Yeah, you could do row 1 minus row 2. You could do row 3 minus row 1. There's a lot of options here to get our 1. So we just pick something. And this is why if you're trying to compare with the person sitting next to you, your matrices might look totally different. That doesn't mean one of you is wrong. It just means you took a different approach, and at the end, it should match up. So which one do you guys want to do?
One, just
Swap them? So row 1 equals row 2. Okay, so now we need to get both of these to be 0. Which row am I going to use to do that? Row 1, because that's the one row we are not changing. So row 2 equals row 2. It is a positive 2, so we need to subtract 2 of row 1. Row 3. Starting with row 3. It's a positive 3, so we would subtract 3 of row 1. So 2 minus 2 times 1 gives us 0. Next one, 2 minus 2 times 1 gives us 0. Next one, 0 minus 2 times 1 is -2. And 6 minus 2 times 1 is 4. For the third row, we have 3 minus 3 times 1 is 0. 4 minus 3 times 1 is 1. -1 minus 3 times 1, -4. And 13 minus 3 times 1 is 10.
Swap row 3 and row 2.
So the next thing we need is a 1 in row 2, column 2. And I currently have a 1 in row 3, column 2. So we could just swap those rows. Now we need everything else in that column to be a 0, which row 3 already is, so we really only have to get that one to be a 0. How would I do it?
Row 2 minus row 1.
And I'm going to do row 1 minus row 2. Here's why. If you did 2 minus row 1, it would turn this first number into a -1, and then we would have to fix that. So rows 2 and 3 are not changing. So 1 minus 0 is 1. 1 minus 1 is 0. 1 minus -4 would be 1 plus 4, which is 5. 1 minus 10, -9.
Take row 3 and just do the inverse, the negative inverse.
So multiply by -1/2. So 0 times -1/2 is 0. -2 times -1/2 is 1. 4 times -1/2 is -2. Last step, what do we need?
To get rid of the other numbers.
Negative.
Those both have to be 0. So row 1 would equal row 1, what?
Minus 5 row 3.
And row 2 would equal row 2
Plus 4 row 3.
So row 3 isn't changing. So 1 minus 5 times 0 is still 1. 0 minus 5 times 0 is 0. 5 minus 5 times 1 is 0. -9 minus 5 times -2. So it'd be -9 plus 10, which is 1. 0 plus 0 is 0. 1 plus 0 is 1. -4 plus 4 is 0. 10 plus -8 is 2. X is 2, or sorry, X is 1. Y is 2. Z is -2. And how can you check these if you need to? Plug them into the original, not just one equation. You would really need to check all of them. Alright, I have a lot of examples of these, so we're going to do as much as we need to really feel confident. Do you guys want to try one on your own and see if we can get it? Kind of give us an idea if we need more class practice or if we're doing okay. Set up your original matrices. And the first one we're good. We start with a 1 in row 1, column 1, so we don't have to do anything for that. We need zeros elsewhere in that column. So if I need both of these to be a 0, row 1 isn't going to change. So I will use that to get my zeros. So what'd you do for row 2? Row 2 minus 2 times row 1. And row 3? So 2 minus 2 times 1 is 0. 3 minus 2 times negative 1 is 5. Negative 1 minus 3 times 1 is negative 4. Negative 2 minus 2 times 8 is negative 18. Next row, 3 minus 3 times 1 is 0. Negative 2 minus 2 times negative 1 is 0. Negative 9, oh, hold on, I put 2. It's 3, isn't it? Negative 2 minus 3 times negative 1. So negative 2 plus 3 is 1. Negative 9 minus 3 times 1 is negative 12. And 9 minus 3 times 8, so 9 minus 24 is negative 15. Are we doing okay so far? What do we need next?
Switch row 3 and row 2.
Mm-hmm. Row 1 stays. And now we have our 1 in row 2, column 2. Now we need both of these to be zeros. So, row 1, starting with row 1, it's a negative, so we have to add row 2. Row 3, starting with row 3, it's a positive 5, so we need to of row 2. So row 2 is the one we're using because it didn't change. So 1 plus 0 is still 1. Negative 1 plus 1 is 0. 1 plus negative 12 is negative 11. 8 plus negative 15 is negative 7. Next one. 0 minus 0 is still 0. 5 minus 5 is 0. Negative 4 plus 60 would be 56. Negative 18 plus 75 would be a big number. Negative 18 plus 75.
Should be negative 3, not negative 4.
I was gonna say something's wrong.
Okay.
Right here. Is that where I messed up?
Yeah.
When we did negative 1 minus 2 times 1, so negative 1 minus 2 is negative 3. I did that on purpose to see if you guys would say anything, and you did not, so.
See, I'm
You guys
pretty
failed.
good at like accidentally adding, subtracting,
Yeah,
adding,
I thought I
negative.
did something.
So I was like, oh, I guess I'm wrong.
So let's fix that. So that would be negative 3 minus 5 times negative 12. So negative 3 plus 60 is 57. That looks a lot better. All right, now what do we want? So row 3 is 1 over 57 row 3.
I was getting a little confused because I was like, multiplying, like adding it by negative 5 times 12, and I was getting like 6.
All right, we are one step from the answer. So now we need these to be zeros. Go okay?
Thank you.
You're welcome. Thanks for coming in.
Yep, no problem.
Good luck today.
Thank you.
So row 1, starting with row 1, it's a negative 11, so we have to add 11 of row 3. Row 2, starting with row 2, it's a negative 12, so we add 12 of row 3. So 1 plus 0 is still 0, 0 plus 0 is 0, negative 11 plus 11 is 0, negative 7 plus 11 is 4. 0 plus 0 is 0, 1 plus 0 is 1, negative 12 plus 12 is 0, negative 15 plus 12 is negative 3. We did not change this. So x is 4, y is negative 3, z is positive 1. Did you guys get that? Did anyone finish